Now what we've done is we've rearranged this system so it has a shaft 1, shaft 2 idle, shaft 3 is a transmission from this 24-tooth gear, terminated at the other end by a 48-tooth gear, and finally the load driven by an 80-tooth gear. So we're going from 36 teeth, idler 36 teeth, 24-tooth transmission to 48-tooth transmission to 80-tooth transmission. Since these two gears are mounted on the same axle, they will turn at exactly the same rate. We can see it when we turn it. Notice this alignment versus this alignment. And I have one revolution here precisely when I have one revolution here. That's because these are tied on the same axis. When gears are tied on different axes, then the speeds are driven by the gear teeth count. When they are driven by on the same axis, then it's driven by the same axis, and it's always a one-to-one relationship. Now notice the speeds as I rotate this. One revolution of 36. You can see this gets the 1.5 revolutions we expect. As this comes up, so does this side. So this is keeping lockstep with this. And at 36, we are at 1.5 revolutions of 24 teeth, which would be 36 teeth. But with the transmission here, this back gear has gone 48 teeth times 1.5 revolutions, or 72 teeth. So now this back wheel has gone 9/10 of a revolution. 72 teeth worth divided by 80 is 0.9 or 9/10. Now what's key here to note there is with the transmission, rather than just 36 teeth, it's gone 72 teeth. We would have expected at 36 teeth to 80 teeth, we would have gone less than half a revolution, but instead we've gone almost 1 revolution. It has doubled the speed of this, mainly by doubling the speed along this transmission axis, 24 teeth to 48 teeth. So what's key here in movement is the speed of this transmission is 36 divided by 24, and then multiply that times 80 divided by 48. When we have that, we have 2 times, the transmission itself adds a factor in speed of 48, the load side divided by the driver side. And so that's the new wrinkle we have there in our calculations, is that we have to allow for this single shaft transmission. So we can't just go from the driver gear to the driven. We also have to multiply it by the transmission gain. In this case, we have gained speed. Ordinarily, if we geared down, we would have gone to a larger gear tooth, smaller gear tooth in the back, and then we would lower our speed. By lowering our speed, we would gain torque, but by raising our speed, we're trading torque for speed. So keep in mind, always, torque and speed are reciprocals of each other. The more speed you have, the less torque you have. The more torque you get, the less speed. Kind of like in a car, going from 3rd gear, 2nd gear, 1st gear. 1st gear gives you the best force, but the lowest speed on wheels. So overall, your load speed compared to your motor speed is going to be your motor speed times your driver gear divided by your driven gear, in this case 36 divided by 24. Then we go to the transmission side to 48, and so your load would be the speed at this wheel, as you've calculated it, times the ratio of 48 teeth, or this tooth, to this, which is 80. So it's again 36 divided by 24, then 48 divided by 80. And that gives you your speed from motor to load.